To see everyone here. I'm very excited and very honored to speak here at the Android Open. So before I start, I just want to say that I flew more than 7,000 miles from Taiwan. It was a pretty exhausting long flight, and if I talk nonsense later, please excuse me, which I will. So since I came a long way, I really hope that I'll make this talk worthwhile for you. The goal here is to talk about some of our experiences in building the HTC Sense, and hopefully that will help most of you in the audience, who I assume are also application developers, in building your own apps or services on the Android platform. So a little introduction about myself. My name is David Wu. You can follow me at that Twitter handle on the screen. I'm an engineer at HTC. Most of what I do at HTC is to design and implement all the social network-related features in HTC Sense. Some of the projects that me and my team have worked on include our recent devices, HTC Chacha and HTC Salsa. Some people call them the Facebook phones. The Accounts and Sync framework, and the plugin architecture in the OpenSense SDK. So, by the way, this is our HTC Dev website. It's only a few months old, and I really encourage you to check it out if you're a developer. So I'm also the author of several apps that come with HTC Sense. Most of them are related to the user's social experience. FriendStream is probably the biggest one. It's an aggregator for all your online social streams. It allows you to read your Facebook status updates and your Twitter tweets in one place. So this is the agenda for today's talk. I'll give hopefully a very brief introduction of HTC Sense, and because of my role in the implementation of the UI framework is mostly focused on social networks, I will focus primarily on the social aspects of the framework. So hopefully that will help set the background for the more technical presentation that's to follow afterwards. I've organized and broken down the presentation to roughly 3 sections. They each focus on roughly one area where we had challenges in. So I'll also talk about how we tackle those challenges, and hopefully that will be meaningful for you. So a show of hands, how many people here own an HTC phone? Okay, you like the HTC Sense. Okay. I see a few hands being dropped, but that's okay. Hopefully you'll change your mind by the end of the talk, and hopefully that's because of my charm. Not going to happen. Okay, anyway, so it's a challenge to talk about HTC Sense because it really means different things for different people. So from a technical perspective, HTC Sense is really just a UI framework that provides a lot of common controls and apps and widgets with which you can customize. So because you can customize your home screen, your lock screen, and your apps so much, everyone really has a different experience, right? So HTC Sense is special because it puts customer at the center. You know, despite the fact that we as developers often talk about the importance of user experience, like building apps that satisfies the user's needs, we actually end up building a product that just meet the next project deadline. In Steve Jobs' words, we start with the technology and try to figure out how to sell it, right, rather than innovating for a better user experience. And this is more true in Asia than here. I know that a lot of tech companies in the Bay Area or in the USA are making great innovative products. So HTC started out as a Taiwanese ODM, smartphone ODM in 1997. As an ODM, we would go about making customizations and manufacture devices that tailor to customer needs. And you probably can't imagine the degree to which that we make customizations for our customers. So as the company gradually transformed itself into establishing its own brand, that DNA, that customizing for the user, that DNA kind of always stuck with us. And we continue to design our phones that center around the user's experience, except that now the customers are no longer just the network operators, but also the end users. So we really try to study user behavior and try to understand what might be needed by the user. So We also try to incorporate that concept into our design process. So we try to design our product in an inwards direction. So we set out to deliver the 4 elements on the outer shell before we decide on any features or any implementation paradigms. And we try to observe what's really needed and what's really expected by the user and putting ourselves in the perspective of the user. So all the features and software implementations come after that. So this is the vanilla Android home screen. You can put app shortcuts and pretty static widgets in your home screen. But they're not very interactive and they're kind of boring. So most importantly, if every manufacturer ships with the stock Android UI, there will be no differentiation and no value, right? So this is the HTC Sense home screen. For those who have had experience with HTC Sense, you would know that not only do we provide an impressive number of widgets, these widgets are actually very interactive and very powerful. You could have scrollable list views, switchable tabs, you can have flippable pages, and you can have clickable buttons, all on your home screen, which is not doable with the Android stock UI. So very early on, we had observed that other than day-to-day tasks like checking your email or event scheduling, contacts lookup or internet browsing, etc., a very big usage of the phone is to stay connected with the user's friends. And it wasn't very easy to check on your friends' recent activities on your various online social networks. You would have to sort of actively go in and out of many different applications and to check on what just what your friend is doing. So we knew that we had to do something to simplify that social experience. So say if we want to check up on a friend, on what a friend is doing recently, we can just go to the friend's contact card. We can find all her contact information in one place, all her short SMS messages, all the emails from her, and all her activities and photos from Facebook, Twitter, and Flickr. So as you can see, these are photos from her Flickr account. So you don't have to go in and out of different apps to check your communication with your friend. Everything can be browsed in one place, and you don't have to really worry about whether you'll miss an activity about your friend. And that makes communication on the phone a lot more like the communication in real life. So we try to simplify that process of checking up on a specific friend's activities one step further. Sometimes you just want to have a quick glimpse of all your friends' recent activities. And we provide that as a widget on the home screen and call it the friend channel. So instead of spending about a second to go into the contacts app, you can quickly check out what your friends is doing right on the home screen. So FriendStream is another great way to keep in touch. It brings together all your friends' Facebook, Twitter, and Flickr updates all in one place. And it means you can keep up to speed to what's happening. So you can check updates, post photos, and share links. And what's great about FriendStream is that you can also update all your timeline, your online accounts easily in one go. And that goes not just for text updates, but also photos and location attachments. So one of my personal favorites is our social lock screen. So this is our lock screen, and we save another second of your time by showing social activities in the lock screen. And you can see beautiful status updates flying across the lock screen. And if you drag an update to the ring in the bottom, we'll let you see the update immediately. And once again, we really try to make everything simple and very intuitive for the user. So another personal favorite is the social caller ID. So when someone calls you, their name and face flash up on the screen. But why do we stop there? So we designed to put more information when they call, like their birthday, their Facebook status, right? And now when someone calls you, you know immediately what topic you can talk about to greet their birthday. So I've just shown you some of the many places in HTC that require access to the user's general online social network data. And all these features we introduced are the results of many user studies in the field. So while all of these features sound like an easy task from a technical perspective anyway, so optimizing that on a mobile device actually is somewhat challenging. So I want to share with you some of the challenges that we encountered along the way. The first challenge is seamlessness. So consider this diagram. On the left are what I call host applications. They're basically applications and widgets living in different process space, right? So like FriendStream or some widget in your home screen. And they need to have access to online social network content. And that content actually comes from various different online sources. They're hosted and processed by what I call social plugins. So an example plugin may be Facebook or Twitter or Flickr, and they each represent a separate application package living in its own process space. So at any given time, a host may need to retrieve content from the plugins in an aggregated or sorted or filtered form. And the content needs to be uniquely rendered for each different social plugin service. So like, for example, your Facebook status update is going to look entirely different from a tweet. So the host may also need to make requests to the plugins when it wants to refresh for new content, or when you scroll to the end of a list, you might want to request to load more content from the cloud. So our first attempt at solving this problem was to use internet broadcast for requests and dynamic class loading for query. So during a request step, the host would broadcast an intent with a predefined format. And when the intent is received by each intent receiver that's registered in the plugins, they would go ahead and fetch content from the cloud. And when the plugins are finished serving the request, the plugins would call back to the host using the same intent broadcast mechanism. So that's how request works. So during what about query? So during a query step, because we want to allow each plugin to have the flexibility in the way they render their content, so we decided to dynamically load Java classes from these plugin packages. So those loaded classes, they take care of retrieving the content from a persistent storage and rendering the content into UI. Well, it turns out that there are many problems with the first approach. So there's a lot of overhead in listening on a broadcast intent. And because it's not an explicit intent, the system gets really busy trying to process that intent. And it's also very difficult to synchronize between requests coming from different hosts, different hosts. So another problem is class loading. Actually, class loading is actually more problematic. It requires the hosts and the plugins to use the same UID. And there's a huge performance penalty due to dynamic class loading. The host process, after loading all the classes in the plugins, it becomes this very fat process, right? And because the host and the plugins are in the same process, it's often very troublesome to debug and to find out which component actually caused the bug. So we gave our second shot at this. During the request step, we would use the native Android remote binder call mechanism, which is basically how Android handles IPC. And to make it asynchronous, we would pass a strong binder to the plugin, and the plugin, after it completes what it does, it'll use the binder to call back to the host. So during a query step, we use a centralized content provider to allow plugins to write data to it and allow hosts to query data from it. The host can then use the standard content observer mechanism to listen on changes in the data. So we also standardize some common data types and provide them as libraries to the plugins. And we also limit how the UI can be rendered and processed, only strings with markup tags. So this new approach works fairly well, but there are still some minor problems that required our attention. So the first and foremost thing is that during our vigorous tests, when the system becomes very busy, database access could be really slow, and it could be blocking for an intolerable long period of time. And these problems can often be tuned with typical database optimizations, such as indexing your tables and optimizing your queries. I'll talk about prepared statements and transactions in my later slides, but we have also tried to reduce the disk I/O by implementing a memcache layer. That worked pretty well. So another problem is that at any given time, there are several hosts that may be listening on the same data with multiple content observers. So when the data changes, these hosts they automatically requery the database, and that could be a disaster. So we modify our the Android framework and use a dirty flag, which allowed us to make requeries only when the content observer is in the foreground. So that concludes seamlessness. The second challenge I want to talk about is sync. As you probably know, there is a sync framework in Android, and it allows you to do background sync of data from the cloud so that your data on the device is always fresh and consistent with the data in the cloud. Now, while that sounds great in theory, the most prominent problems with the background sync on a mobile device are basically bandwidth and battery usage. So the more you sync, the more bandwidth you consume, and the longer you sync, the more CPU cycles you use, and the more battery you drain. So very early we realized that it's a problem that requires a trade-off solution. So you want to have, the more often you sync, the more fresh your content is, right? But also the more bandwidth and battery you use. So there's always going to be a trade-off. So HTC really cares about these problems. I can't disclose any actual sales numbers, but to put things in perspective, 2 out of every 5 Android phones sold is an HTC device. So 1 out of every 2 Windows phones sold is an HTC, and every 0.68 second there is a new HTC phone activated. So in other words, there is a lot of HTC devices out there. So who would really care about this problem? Naturally, our network operators, they care about that because we're using their infrastructure and we're using their bandwidth. And so are those online services like Facebook and Twitter, our partners. The users really care about that too because a battery drain would really piss them off. So if you go to the forum and check out some of the comments that our users give us, you'll know how much they care about this problem. So there are 3 general approaches to tackle this problem. We'll go through them one by one. So the first one is basically to monitor your device states and act accordingly. So for example, if you're on a GPRS connection, or if you're already running out of battery, and for example, if you have very limited free space left, it would make sense to not do a background sync at this time, right? So I'm not going to go into too much detail here because it's already well covered at Google I/O. So if you haven't, I recommend that you check out Rito Meyer's Android Pro Tips session at Google I/O 2011. But basically the idea is that you monitor the device states and you act accordingly, whether you want to continue with the sync or you don't. So the second approach is to not sync everything, right? You only want to sync important data. So on HTC devices, we allow the user to mark explicitly who are their favorite contacts. And we also have several ways to figure out, who are your most important contacts. We check your, activities with your friends and how often you actually interact with those users, and then we determine whether that's an important contact or not. So by syncing only for a subset of contacts, that will allow you to consume less content. So another example is that you sync only a max number of posts. Consider a timeline where on the left is the most current time, and on the right is, in dark green, are stream posts we already have locally on the device, basically old content in the past. So suppose we're now asked to fetch for new posts from the cloud. And you would waste a lot of bandwidth and battery to fetch everything up to the most recent data that we have last fetched. And we really just need to fetch the most recent content and leave a gap in the timeline and somehow allow the user to fetch for more content if he wishes. So other than fetching less content, you want to avoid fetching the same data or writing the same data twice. One of the things that you need to do when you sync is that you need to compare old content with new content to see if there is any updates needed. Comparing two data objects can take many CPU cycles. If you use a hash function to compute the hash values of these data objects and use the hash values for comparison, that will save you a lot of CPU cycles. So one of the most confusing thing is that people tend to use the native Facebook app, the native Twitter app, and very recently the native Flickr app as well. So that means the Facebook app would try to sync Facebook content themselves, and we sync, HTC Sense syncs the same set of content too. And that makes no sense because you're fetching from the cloud twice for the same data, right? So we're working very closely with our partners on this matter so that we can come up with a deeper integration and try to avoid this. And this is in the works. So the third approach in doing a better sync is what we call smart sync, to use application heuristics that make sense to your application. So for example, it probably makes more sense to do a background sync of your data only when there are widgets installed on your home screen. And if you have a social network account that's not very active and has very few content, very sparse timeline, there is no point in doing a background sync very often. So that sums up our three approaches to consume less power and bandwidth when doing a background sync. The third challenge we have encountered has to do with performance. So, sorry. So we have done a lot of work in the application framework layer. At the application framework level, we do stuff like adding more common controls, and we try to add a lot of debugging capabilities to that level, to that layer. We also have a lot of extended components to help basically augment the stock Android application framework. Now, all of that work in the application framework layer is so that we can write our applications more easily. And at HTC, we write a lot of, like a very large number of applications and home screen widgets on top of that layer, right? So because we write so many apps on a daily basis, we've probably come across most of the common bugs that application developers run into. So I've summarized some of the common issues related to performance here in this section, and I hope that by sharing our experience, many of you will find it beneficial in writing your own apps. So the first one is, at several occasions in HTC Sense, we have to basically aggregate content retrieved from multiple data sources. Usually they're from the cloud or from data storage on the device via content providers. We have to sort them and we have to display them on the screen. So a normal, intuitive first attempt to tackle this problem would be to collect all the data and do a quick sort on all of that content and display the sorted elements one by one on the screen, perhaps in a list view or in a grid view layout. Now, the problem with that is you need to have all the content in memory to do the quick sort. This is not always possible if the number of contacts you have is very large. So if you're like a celebrity, like Robert Scoble, you would have like tens of thousands of contacts on various social networks. And doing an in-memory quick sort of that number of contacts on the device is nearly impossible. And even if it was possible, the initial sort, even though we call it quick sort, it actually takes a long time and makes your application appear to launch longer than it should. So a better way to do this is to rely on the native SQLite sorting capability and do a merge sort. So most data sources come with a native sorting capability. In the case of SQLite, you can actually add a order by clause in your query statement. And they're usually optimized already and have pretty good performance. So we leverage that and we pre-sort each data source with SQLite. And then we do a heap sort on each of the next available record from each data source. And at any given time, you just keep a set of pointers to the next available record in each data source, and you only sort that set of next available records when you scroll to a new position in the UI. So essentially, this allows you to amortize the sorting cost while you scroll down the list view. So this method has nearly no startup cost, and it makes your app extremely snappy. So using this method, it allowed FriendStream startup time to go from about 1.8 seconds to 0.6 seconds. And the same technique, because it's so great, we use the same technique in all our other apps, such as contacts or messages or calendars, etc. Now, the first impression users have about an app is usually about its launch time. And if the app takes more than a couple of seconds to launch, the user could really quickly lose interest and decide that, to give you a bad review or a bad rating. So I'll talk about a number of things that we can do to reduce the application launch time. So for an application to be considered having completed its launch, it has to finish drawing all of its views and finish making queries to some data. So there is a style attribute in Android called the window background, which is basically an extra view called decor view. That's the parent to the rest of your application layout. You can fool your user by setting the window background to paint an image that looks very similar to what your application would look like had it finished launching itself already. So this is what we usually call a face screen. It doesn't really improve your actual launch time, but it improves the launch time as perceived by the user. So unfortunately, there's a problem with that in the Android framework. The Android framework is not able to tell you if a parent view is partially or fully hidden from an opaque child view. So it keeps drawing the parent view even if it was hidden behind an opaque child view. And drawing that unnecessary hidden parent will slow down your performance. It'll actually reduce your frame rate by about 5 to 10 frames per second, depending on various factors. So you want to make sure that you reset the window background after your application finishes its launch. You can do that in code with getWindow.setBackgroundDrawable and pass a null pointer into it. So a second thing that you can do to reduce your application launch time is to basically reduce your layout complexity. And there is a couple of things that you have to do, but basically basically what you want to do is that you want to make your hierarchy shallow as possible. And there's also a tool called Layout Optimizer that could help you find out where in your layout has a problem. I'm not going to go into detail here, but because Romain Guy, one of the Google engineers on the Android team, already has a lot of posts about this on the Android developer blog. So I would encourage you to go to the Android developer blog to find out more about how to reduce your layout complexity. So, okay. So very often when we launch an application, it tries to make queries to some database. And optimizing that time spent on the query is obviously very important in optimizing your application launch time. And each database query involves filling a memory window. And a memory window is something like a cache, right? You fetch records from your database, and you store parts of that result set in the memory. And filling the windows is really the bottleneck of of all database queries. So to minimize that fill window time, you can minimize either the number of columns or the number of rows in the result set. If you want to reduce the number of columns, basically you just want to reduce the number of columns that you select, right? And to reduce the number of rows, you just use limits. Okay. It's also very important to profile your SQLite queries so that you know what can be done to further optimize your query. So what I really want to talk about is prepare statements. Earlier, when we talk about query optimization, I also mentioned you can use prepare statements and transactions to help you optimize your queries. So prepared statements, they allow you to precompile frequently used SQLite statements. They improve your performance by, number one, reducing the deallocation of string objects, and number two, reducing the overhead in parsing a statement. So this is how you would do it, but you can check out the code detail on the Android developer documentation. So people often don't realize that grouping a lot of operations in a transaction not only provides consistency, but it also improves your performance. So our benchmark results reveal that if you do many insert statements in a loop, it's actually quite costly. But if you do them in a transaction, there's a lot of performance gain. And if you do a transaction in combination with prepared statements, you have even more gain. Right? So the performance gain is so great that you probably want to consider using transactions in apply batch or bulk insert. You might want to override your original content provider implementations and use a transaction instead. So note that if you group too many operations in a transaction, it might actually block the database for a long period of time. And depending on what your application requirements are, that may not be ideal. So the number of operations in a transaction should be derived empirically. You might also want to do partial transactions by adding a yield statement somewhere within a long transaction so that other processes can go in. All right. So if you have a huge list view with lots of data, then each list item requires a lot of work to render. You'll run into scrolling performance issues. So basically what you want to do in minimizing scrolling performance is that you want to minimize both getView method in your list adapter and also the draw method of your views. So the first and foremost thing you want to try to check is to use convert views and avoid find view by ID in your getView method calls. So a lot has been said by Romain Guy already, so I won't go into detail here. Another thing is that you want to avoid setting a window background. So having this is basically what we already said. Having a window background could really slow down your performance. It could slow down your performance from 60 frames per second to like 25 frames per second. So you also want to avoid runtime scaling of images. So if your image view is like, say, 100 by 100 pixels, and you want to make sure that your image is pre-scaled to the correct dimensions. Instead of scaling it every time, you set it to the image view. Another common mistake that's overlooked in our experience is with bitmapFactory.decodeStream. So every time you call this method to decode a bitmap, a new byte array is allocated. And if you do this for each of your list item, the byte array is going to be allocated and garbage collected each time. So you want to reduce this the number of byte array allocations by passing your own into the bitmap factory using options class. So as a last treat, I have included a slide that talks about some general coding practices that could drag that last bit of performance out of your application. So the first one is to use system.array copy when you want to copy an array to another using a for loop. So the first line of code copies one array to another, element by element. That takes about 315 milliseconds. So the second line of code, which uses system.array copy, spends only about 29 milliseconds. So that's like a 10 times speed up in performance. All right. So Google has actually hidden some pretty useful helper classes in the Android framework, and they're usually stored in the com.android.internal namespace. One of my personal favorites is the ArrayUtils helper library. It helps you to initialize the ideal capacity of a collection. So as you know, if you have too small an initial capacity of your collection, each time you try to add an element that exceeds that internal capacity, there will be some penalty in increasing that capacity. So this is a pretty good helper class that helps you find out what's a good size for your initial capacity. All right. So another obvious tip is that if you know you're going to allocate a lot of objects in the loop, try to use an object pool to minimize your garbage collection. A garbage collection before Gingerbread could take up to like 200 and 300 milliseconds, and that's noticeable to your user. So you want to, that will make your application really slow. All right, so that's about all the slides that I have. Thank you all. I hope that was helpful and useful. So it's a really great pleasure to speak to all of you. Thank you very much. So we probably have time for a few questions in the crowd. So if you have a question, just raise your hand and go to the mic. No questions. Wow. That could be very good or very bad. Sure.
Can you tell us a little bit about how you do profiling of your code? So essentially for figuring out where to, which battles to fight, where to invest time in optimizing?
Sure. There's actually a lot of tools provided by Google. So for example, we use a lot the method profiler utility. It helps you identify like where in your code is taking the most amount of time. So you can do that, use that to help you figure out where the bottleneck is. So I hope, did that answer your question? Okay.
Nobody else is asking. How does the Sense strategy, in your mind, on your view, compare to what others are doing in the mobile space, Android mobile space, so TouchWiz or MotoBlur, and so on and so on? How are you guys superior or different than others?
Okay. So if you are a user who has used MotoBlur and HTC Sense, you would know that we actually do a lot more than what they do, right? I mean, like if just the pure number of customizations we make in HTC Sense is just like overwhelming. So I think that puts us in a good spot because we actually do care about the user and we really think about the user experience before anything. So that's one of our biggest advantages, and when you're talking about comparing to other UI frameworks.
David, from a SoC perspective, any particular preference that you guys or your experiences with a particular system on a chip or a processor that you guys have had experiences with that you would like to share, please?
I really can't answer that question. So, yeah, because we try to work with all the chipsets. There may be preference one over the other, but we still try to work things out with all of our partners. Hope that answers your question.
If you don't mind, another one. Another one you probably can't answer, but nevertheless, what do you expect from Sense 4.0 and onward, in terms of general direction, if not specific features?
Right. Again, we do a lot of user studies in the field, and so in Sense 4.0, we're going to add a lot of new new features that tailor to customer needs, like make things a lot simpler. We want to simplify every task that they have. But other than that, I can't really say much. Right? That's it. Thank you.